Welcome to Chemistry with Miss Asmus. Today we're in my kitchen doing some experiments on gas laws and how gases interact. So today we will be using a pop can. Right now I just have a can of Mountain Dew, 10 milliliters of water that I have in my graduated cylinder here, and a bowl of very cold water that is currently in my freezer chilling at this moment. So throughout my experiment today, I want you to think about the gas particles that are in this Mountain Dew can. Even though there's nothing in this can, or it seems like there's no solids or liquids in this can, there's gas in this can, just like there's gas in the air around us. So there are gas molecules in this can, and think of what they're doing. Think of how they're hitting each other, hitting the walls, and we're going to think of those properties as we change the temperature of this can. So right now I'm going to be adding water into this can and then creating water vapor on the stove. I'll set this can on the stove and we'll create water vapor that will move around this can. So here the water goes into the can, and now my stove is on and I'm going to set this on there and watch until steam is coming out so that we know that that water is turning to vapor, is turning to steam. While that can is on the stove with that water turning to vapor, liquid turning to gas, let's talk about those 3 gas laws we learned earlier this week. The last one was Charles' law, and that's the relationship between volume and temperature. So if we increase the temperature, those molecules are going to be moving faster and faster, they're going to be hitting the walls more and more, which means it's going to expand. So a higher temperature means a higher volume. I want you to make a prediction. So now I'm going to take out my cold water. We'll be going from an initial high temperature of this water vapor, and I can see it rising out of the can right now. So we have water vapor that is at a high temperature inside of this can, moving around, and we have a very cold bowl of water right here. And I'm going to be putting that can upside down into this bowl of water. So now is the time to make a prediction. When we move something that's really hot to really cold, what will happen to the volume of that can? Now that you've made those predictions, let's see what happens when we actually put that can of really hot water vapor into this water. Safety first, I'm going to take my tongs and I'm going to grab it off the stove, and I'll be putting it in upside down into this bowl of water. So here's my hot can. Did you hear that crushing sound? You can see that this can has been crushed. And I didn't do that with the salad tongs. I simply placed it in the water and it was crushed. So now let's create an explanation. Why did this can crush? Why did the volume decrease? What was happening to those gas particles when they were in here at a very high temperature and I placed them inside very cold water? Awesome job making those explanations. So we are thinking about those gas molecules in this can. They're moving around at a really high speed, and then we take them and we put them in the cold water, and right away they start to condense back to water from the gas that they were. This means that there's empty space in our can. Those molecules aren't hitting the wall as much. Those molecules moving around less, they're not moving as fast because they're getting cold right away, which means they're not hitting the walls as less. And when that happens, that volume comes in and it goes down. And that is what Charles' law tells us. And you can try this at home. All you need is a stove, a can of pop, and 10 milliliters of water, or just means a little bit of water, and then a bowl of cold water. Happy sciencing!